So good day. Today we're going to tackle about the beta binomial distribution. So beta binomial distribution is given by f of x, where f of x have a parameter n, alpha, and beta. So the equation is given by n taken x times the gamma times alpha plus beta over gamma of alpha times gamma of beta times gamma of x plus alpha times gamma of n plus beta minus x over gamma of n plus alpha plus beta with indicator from 0 up to n, where n is a non-negative integer and alpha and beta are greater than 0. Now we are going to show that the expectation of x is equal to n times alpha over alpha plus beta. So note that the summation of f of x from 0 up to n is equal to n taken x times gamma of alpha plus beta over gamma of alpha times gamma of beta times gamma of x plus alpha over gamma of n plus alpha plus beta times the gamma of n plus beta minus x over the gamma of n plus alpha plus beta is equal to 1. Now we're going to derive the formula for getting the mean of the beta binomial distribution. So expectation x is equal to the summation of f of x, where x is equal to 0 up to n. So we're just going to substitute the value of f of x, which is the n taken x, gamma, and this one. Then so next is we have this summation of x times n factorial over x factorial times n minus x factorial times the gamma of alpha plus beta plus 1 over alpha plus beta times alpha over gamma of alpha plus 1 times 1 over gamma of beta times gamma of x plus alpha times gamma of n plus beta minus x over the gamma of n plus alpha plus beta. So it is equal to the summation of alpha over alpha plus beta. So just going to simplify times x, then the n times n minus 1 factorial over x times x minus 1 factorial times n minus x factorial times the gamma of alpha plus beta plus 1 times 1 over the gamma of alpha plus 1 times 1 over the gamma of beta times the gamma of x plus alpha times the gamma of n plus beta minus x over the gamma of n plus x plus beta. So we're now going to pull out the constant out from the summation. So we have the alpha times n over alpha plus b times the summation of n minus 1 factorial over x minus 1 factorial times n minus x factorial times the gamma of alpha plus beta plus 1 over the gamma of alpha plus 1 times gamma of beta times the gamma of x plus alpha times the gamma of n plus beta minus x over the gamma of n plus alpha plus beta. So we have this alpha times n over alpha plus beta times the summation of n minus 1 x minus 1 times gamma of alpha plus beta plus 1 over gamma of alpha plus 1 times gamma of beta times the gamma of x plus alpha times gamma of n plus beta minus x over the gamma of n times alpha plus beta. So to simplify, we have gamma of n times gamma plus beta, since this one is equal to 1, so we have the expectation of x is equal to gamma times n over gamma plus beta. And so now we pull out the constant, which is the alpha times alpha plus 1 times n minus 1 over the alpha plus beta times alpha plus beta plus 1 times the summation of n minus 2 factorial over x minus 2 factorial times n minus x factorial times the gamma of alpha plus beta plus 2 times 1 over gamma of alpha plus 2 times 1 over gamma of beta times the gamma of x plus alpha times the gamma of n plus beta minus x over the gamma of n plus alpha plus beta. So we have, it is equal to the alpha times alpha plus 1 times n minus 1 over the alpha plus beta times alpha plus beta plus 1 times the summation of n minus 2 taken x minus 2 is times the gamma of alpha plus beta plus 2 over the gamma of alpha plus 2 times gamma of beta times the gamma of x plus alpha times the gamma of n plus beta minus x over the gamma of n plus alpha plus beta. So we have this alpha times the alpha plus 1 times n minus 1 over alpha plus beta times alpha plus beta plus 1 times 1, since the summation of is equal to 1. Next is we have, so to simplify, we have the alpha times alpha plus 1 times n minus 1 over alpha plus beta times alpha plus beta plus 1, which is equal to, if we simplify, if we operate, we have this alpha squared plus alpha times n squared minus n over alpha plus beta over times alpha plus beta plus 1, which is equal to the expectation of x squared is equal to n squared alpha squared plus n squared alpha minus alpha squared n minus n alpha all over alpha plus beta times alpha plus beta plus 1. So now to solve for the variance of x, since we have the value for expectation of x squared and expectation of x, so we have this substitute this one. So we have n squared times alpha squared plus n squared alpha minus n alpha squared minus n alpha over alpha plus b times alpha plus beta plus n plus the mean, which is the alpha times n over alpha plus b times the square root of alpha times n over alpha plus b, so which is equal to this one. So to operate algebraically, we have this alpha plus beta times n squared plus n squared alpha minus n alpha squared minus n alpha plus alpha plus beta times alpha plus beta plus 1 times n alpha minus alpha plus beta plus 1 times alpha squared times n squared all over to a alpha plus beta squared times alpha plus beta plus 1, which is the less common denominator of this one. So to simplify it all, so we have this one, and so we have the variance of x is equal to n squared alpha beta plus n alpha squared beta plus n alpha beta squared all over alpha plus beta squared times alpha plus beta plus 1, which is equal to n alpha beta n times alpha times beta times n plus alpha plus beta all over to alpha plus beta squared times alpha plus beta plus 1. And now let's talk about the logarithmic distribution. So f of x with parameters p is equal to q raised to the power of x over negative x log sub log of p sub e for x is equal to 1 up to n. Otherwise, this is 0. So this is equal to q raised to x over negative x log of p sub e with indicators 1 up to n of x. So So the parameter satisfies that p is greater than 0 but less than 1, and q is equal to 1 minus p, and is defined as the logarithmic function. So we need to find the expected value of x, which is q over negative p log of p sub e, and the variance of x, which is q times q plus 1 log of p sub e over negative p log of p sub e squared. Solve for the mean of the logarithmic distribution. We have this summation of x f of x, where x is equal to 0 up to n. So we substitute the value of the f of x here, which is the q raised to x over negative x log of p sub e. So this one can be transformed into this equation. So wherein we can pull out the constant, which is the q over negative log of p sub x times the summation of x times q raised to x minus 1 over x, where starts from 1 up to n. And since x can be cancelled, so na siya mabilin. Then this one, so up here, so it will equal to q over negative log of p sub x times 1 over 1 minus p times the summation of 1 minus p raised to x. So it is equal to q over negative log of p sub x times 1 over 1 minus p times the summation of q raised to x, where q is equal to 1 minus p katong sa kani. So is gi-substitute ang q, then we get that q over log of p sub x sub e rather minus p log of p sub e times the summation of q raised to x, where x starts from 1 up to n, is equal to this one. Substitute 1 to the value of q, so the mean is equal to q over negative p log of p sub e. End of proof. Solve for the variance of x given this formula: summation of x minus mu quantity squared times f of x, where x starts from 0 up to n. So we're just going to substitute for the value of the mu and the given f of x. So we have this summation of x minus q over negative p log of p sub e quantity squared times the q raised to x over negative x log of p sub e. And then we're just going to operate it algebraically. So we have this x squared minus 2x q over negative p log of p sub e plus q over negative p log of p sub e quantity squared times the q raised to x over x minus negative x log of p sub e. So we're just going to combine it by using the LCD. It's LCD, so we have this x squared times negative p log of p sub e squared minus 2x q times p log of p sub e plus q squared over negative p log of p sub e quantity squared times q raised to x over negative x log of p sub e. So we have this var of x is equal to q times q plus log of p sub e over negative p log of p sub e quantity squared. End of